fluid coding, and AI. Today, we are building the model router I would actually trust for coding agent work, strong model for planning and review, DeepSeek V4, Flash for fenced execution, and a comparison against single model baselines that does not pretend one benchmark proves everything. Here is the warning label. The available first-party report tested OpenRouter DeepSeek V4 Flash across all benchmark suites and landed at 31.31% overall. Coding was the only category with non-zero points. Data interpretation, planning operations, quantitative reasoning, safety policy, source research, and writing editing all scored 0 in that run. That is not a universal model judgment. The report does not include routing mode, temperature, retries, or prompt settings, but it is enough evidence to stop treating Flash as the planner. The useful question is not, can Flash replace Pro? Based on this evidence, that would be the wrong question. The useful question is, can a router protect the expensive reasoning steps while still using cheap, fast tokens for work that is already constrained? If the answer is yes, the win is not model quality in isolation. The win is better system behavior, fewer wasted frontier calls, clearer escalation, and less money spent on chores that tests can verify. DeepSeek announced V4 Preview as live and open-sourced. In DeepSeek's own docs, V4 Pro is listed as a 1.6 trillion total parameter model with 49 billion active parameters. V4 Flash is listed as 284 billion total parameters with 13 billion active parameters. The API pricing page also lists both model names with 1 million context length, large maximum output, tool calls, chat prefix completion, and fill-in. The middle completion in non-thinking mode. So the interface is similar, the risk profile is not. As retrieved on June 11, 2026, DeepSeek's own pricing page lists V4 Flash at 14 cents per million cache miss input tokens and 28 cents per million output tokens. V4 Pro is listed at 43.5 cents input and 87 cents output. OpenRouter lists different V4 Flash prices on its model page, 9.83 cents input and 19.66 cents output per million tokens. That difference matters because provider, routing mode, cache behavior, and hosted backend can change the economics. A model router chooses which model should handle each request. Not Diamond describes routing as selecting the best large language model from candidate models for each query to improve accuracy while reducing cost. Light LLM documents production router features like load balancing, fallbacks, timeouts, retries, cooldowns, queuing important requests, and content-based auto-routing. That is the mental model I want here. A router is not a cheaper model hiding behind one endpoint, it is a control system. The split is simple. Send planning, architecture, ambiguous debugging, migration ordering, security review, policy judgment, source research, and final diff review to V4 Pro or a frontier model. Send Flash the leaf work after the plan is written, narrow edits, format conversion, JSON normalization, changelog drafting from commits, clustering test failures, summarizing logs, simple tool calls, and repetitive refactors. Flash should receive a bounded task, clear acceptance checks, and permission to fail fast. The core pattern is plan once, execute many. First, the strong model turns the user request into a task graph, files to inspect, changes to make, acceptance tests, and rollback notes. Then Flash gets one leaf task at a time. If Flash edits outside the assigned scope, produces malformed JSON, fails tests, invents sources, or asks to make broad judgment calls, the router escalates. The strong model repairs the plan or takes over the task. A good Flash demo is not, please solve the whole bug. A good Flash demo is, here are 20 failing test logs, cluster them by failure mode, include file names, include the repeated assertion text, and return valid JSON. That output can be checked. A schema can validate it. A stronger model can read it and decide the real fix. Flash saves time by compressing noise, not by owning the diagnosis. The comparison I would run has 3 lanes. Lane 1, single DeepSeek V4 Pro handles planning, execution, summarization, test triage, and review. Lane 2, one frontier model, such as GPT 5.4.8, handles the whole workflow. 8 handles the whole workflow. Lane 3, the router uses V4 Pro or a frontier model for planning and review, then sends bounded chores to V4 Flash. The available evidence does not contain those side-by-side results yet, so these are test lanes, not a claimed outcome. Do not score the router by vibes. Capture input tokens, output tokens, cache tokens when available, estimated cost, wall clock time, time to first useful output, tool calls, failed tool calls, retries, escalations, and final test results. Then add human review findings, correctness, overreach, missed edge cases, file churn, source citation quality, and whether the agent looped or hallucinated missing APIs. A cheaper run that needs 3 repairs may not be cheaper. The reason to keep a stronger model in the loop is compounding error. A bad plan can create 10 bad subtasks. A weak review can accept a patch that passes narrow tests but breaks the product boundary. OpenRouter describes V4 Pro as suited for advanced reasoning, coding, long-horizon agent workflows, full code-base analysis, multi-step automation, and large-scale information synthesis. That is exactly the kind of work I do not want delegated to Flash without stronger evidence. Implementation does not need to be exotic. Start with a task classifier. If the request includes planning, architecture, review, security, policy, source research, migration, rollback, or ambiguous debugging, choose the strong model. If the request is narrow, reversible, and checkable, and a plan already exists, choose Flash. Wrap every Flash call with a schema, a timeout, a retry limit, logs for provider and model metadata, and an escalation path back to the strong model. There is also a broader reason this design is plausible. Frugal GPT, a 2023 research paper on large language model cascades, reported that cascades could match the best individual model with up to 98% cost reduction, or improve accuracy over GPT-4 by 4% at the same cost in its experiments. That is prior evidence for cascades as a concept. It is not proof that this DeepSeek router will get those numbers. My verdict is, build the router, but make it conservative by default. Use strong models where the system needs judgment. Use V4 Flash where the task is bounded, reversible, and objectively checkable. Measure the router against single V4 Pro and a single frontier model baseline, using the same task, same repo state, same controls, and preserved logs. If the router wins, you have evidence. If it loses, you still learned where cheap execution creates hidden cost. If this helped you think more clearly about model routing, hit like and subscribe to Fluid Coding and AI for more practical breakdowns of coding agents, model trade-offs, and developer workflows.